Writing equations. The graph of y equals g of x represents a transformation of the graph of y equals f of x. Write an equation of g of x in the form y equals a of f of b of x minus h plus k. Alright, first we want to look at reflections and stretches. We need to apply those first before we can translate the graph. So the first thing I do is I analyze the graph for reflections. This is my f of x, my original graph. My g of x is the graph after the transformation. I can clearly see it's flipped over the x-axis, so we can make note of that. Reflects x-axis, okay, which ultimately means that we would be multiplying the y value by -1. Okay, I'm also going to just double check about the y-axis reflection, and I don't see a reflection. I can tell it's wider here at this side of the shape than here, which is same. It's still wide on the left side compared to the right side, so I know it didn't reflect over the y-axis. Okay. Next, I'm going to look for any vertical or horizontal stretches. I can clearly see a horizontal stretch. To help me with that, I'm going to look at the domain. If I look at the domain here, this was at our scale is -2 to 2, so it was 4 units originally. And it is now, if we take a look, from -7 to 13, so that's 7 this way, 13 this way, so that's 20 units that it changed to. So I want to think about from 4 units to 20. So 4 times what number is going to give me 20? So I like to write it out this way. I can tell that's 5. So that means that the x values were multiplied by a factor of 5, which tells me my b value is the reciprocal of 5, which is 1 over 5. Let's compare the range. If I look at the range, it's 4 units originally, 4 units afterwards. So when I look at the range, there was no change. So since there was no change, that means there is no vertical stretch. Alright, so what I need to do is I need to pick a point on my f of x graph and apply the stretches and reflection, and then find that corresponding point. So let's do that next. So apply our horizontal stretch and reflection to a point. Okay, so on f of x, I'll pick a point. So let's just pick our point -2, 0. And I'm going to apply a horizontal stretch, so 5 times the x. The b value is 1/5, but by a factor of 5. And our reflection, so -y. So when I apply this, -2 times 5 gives me -10. -1 times 0, I still have 0. Okay, I'm then going to locate this point and count to the image point. So the image point is the point that is the same corresponding point on your new graph. So I'm going to locate -10 and 0, so that's right here. And I want to locate it to the image point. So the image point of my new graph is going to get me to count it to the right, 1, 2, 3. Remember that each square is 2, so this is a distance of 3. So to get to my image point, okay, we moved 3 to the right. Therefore, when I put all of this together into my equation, we want to put a negative for our reflection in front of the f. When we open our brackets, we want our 1/5 for our b value. And now we've got to put in our horizontal shift of right 3. And there was no vertical shift. When I counted in 3 to the right, I was able to get to my image point.